And welcome back. This is A-Level Concern Answers Connect Paper 4 and this is Python tutorial O part 4, and today we are going to move on and we're going to discuss about polymorphism. That's what we're going to discuss, and we're going to discuss about destructor. Okay, and then we're going to discuss about garbage collection, and then we're going to discuss about containment. Okay, containment, right. Now let's start from polymorphism. Okay, so what is polymorphism? Let me open my writing pad. Okay, it's loading, it is loading, and it's working. Okay, so polymorphism is whenever we are talking about polymorphism, it means that let's supposing you have created a class. Okay, and inside a class you have methods and you have a constructor. Let's say you have methods. Okay, now in polymorphism there are two things to understand. One is method overloading, method overloading, right, and the another thing is method overriding. Let's suppose okay, method overloading means that you have same method name, like for example walk, no parameters, walk having parameters like integer, and and you have a walk which is string. I mean, there are so many method of the same name, but the difference between these methods are the having the number of parameters or not. Different data types having parameters or not, one parameter, two parameter, different data I mean different having passing different parameters. Okay, either and also depend on the position of the parameters. Okay, like for example string. Okay, I'm writing in Java for sorry about that. So let me just say let me say name, age. Okay, these are two parameters. This is the order, or I can write another method but different order of the parameters: age, name. Method overloading, you are overloading the methods. You are creating different method of the same name but different parameter, having either different orders or different data types, or having 3, 4, or 1, 2 parameters. You are making a difference just by choosing how many parameters you wanted to pass, right? You are making a difference in depending on the different data type of the parameter that you are passing. You are making a difference on the order of the parameters. So overloading means create as many method of the same name as you want it, but bear in mind that you need to make a difference between these methods, like which I just gave you the example, right? So this is method overloading. Method overriding is done in inheritance. Okay, so for example, whenever you have a parent class and the parent have a method like walk method, which is walk. Okay, let's suppose a father is walking like a gentleman, and the child is also trying to learn from his father, but the child may walk differently, the father may walk differently. So child inherit the properties of the father, and it can override this. Instead of walking like the father, it can change, it can you can say evolve its own way of walking. So override keyword will come, override, and override walk. For example, the code is this. Sorry, I'm writing in Java, but okay. Print. I'm walking like a gentleman, etc. And in here, I'll just say I'm walking like a child. Okay. So this is overriding, because your overriding means override the methods, overriding the methods of the parent. Okay. How will you override it? By writing the same method name. The method name must be same. It's the only way to override the parent methods. Okay, so this is polymorphism, and now let's come back to coding. Right. Now supposing I'm creating a class human, let's say parent. Okay, class parent, and then I got the in itself. Okay, this is a constructor, and now I'm creating the method, let's say walk. Okay, print walking like a gentleman. Okay, so this is method 1. Now I can create the same method with the same name but different data type. Walk self and name. I am walking like that celebrity, like a celebrity. That celebrity name is name. Okay, I'm trying to walk like that celebrity because I'm a big fan. Okay, let me create another method of the same name, def walk. Okay, and age. I don't. Okay, it's should be, yeah. I don't walk like an old man. I am age years old. Okay, so these are the three methods, but they have the same name but different parameters, name, age, and sometimes there is no parameter. So this is overloading, this is polymorphism overloading. Okay, so if I try to create an object, okay, let's say parent1 is equals to parent. Okay, and there's nothing to to pass, right? And parent, or wait, let me just make this much more clear. Let's say p1. Okay, so p1 dot walk. If I run this, so it should work. Okay, it's not working because, okay, so if I run these two methods like p1 dot walk Harry, so p1 dot walk Harry, I'm walking like the celebrity. Okay, but if I run this empty without any parameters, then I'm walking like a gentleman. So this is how you can create method. This is the only way to do overloading. Okay, this is how you can do in overloading through Python. Creating another class child, and I'm going to inherit the properties of the parent, and then def slash slash. Okay, and I'm going to, like I've done in here. Okay, parent dot in itself. Okay, so this is one way, and Now I want to override the methods. Okay, so if I can override this by you're writing down the same name. Okay, there you go, and then print I am a child, my name is, and then you just write it down. Okay, I can do the same thing if I just write. So if I'm walking like a child. Okay, so now this method is overriding this one. Okay, so this is how you can override by writing down the same name, same parameter. Now if I just create c1 is equals to child, okay, and then if I c1 dot walk, and again c1 dot walk with a name Ali. Okay, run this, and okay, so this is now working. I'm walking like a celebrity, I'm walking like a gentleman, I'm walking like a child. I'm walking like a child because I'm having no parameters, and then I'm a child, my name is Ali. So okay, so this is how you can do overriding in this way, right? And overloading as well. Okay, okay, so c1 dot, now if I see this is the child method. There is no parent method because it has been overridden. Okay, but if I make some difference, for example, I write down walk 1. Okay, so if I do walk 1, then what will happen? Write down, and then there you go, parent method is being shown in the child, because first we did inherit the parent, but the name is different. If the name was same, then the walk method would override the method of the parent. Okay, which is, we can say that this overriding is being successful. So if I remove this again, and if I show you, then there you can see that there is no parent method in here, it's only the child method. It has overridden the method of the parent. Okay, so this is how this polymorphism works. Let's move on, and let me comment this. Okay, so polymorphism is done. Now destructor, here we go, destructor. Okay, let me, let me just use this instead. No need to waste my time. I'm just going to remove this, and let's call that is, let's create, okay, let's talk about destructor. Okay, like I just told you guys about the constructor, and then there is this destructor. Okay, constructor means construct the memory, construct memory, creating an object. Okay, creating an object. Destructor means destruct the memory. Destruct the memory, delete the object, or destroy the object. So let's see the implementation, that how we can use the destructor. Okay, let's see. This is the constructor. This is how you're constructing a memory, and this is, wait, till, this is a destructor. This is how you can destruct the memory, create, I mean deleting the object itself. Shape delete it. Okay, so oh wait, sorry, not shape, but actually the parent object is deleted. Now I created the parent object using the constructor. I just call the method and then I deleted the parent method, I mean the parent object. And then after that I tried to call a method. So if I run this, then okay, so what's happening here? Does not match. Okay, there's indentation error. Right, now it should be fine. P1 is not defined. Okay, so now you can see here I'm walking like a gentleman and parent object is deleted, and this confirmed that yes, the parent object is deleted because after calling this method name P1 is not defined. So this is how you can create a destructor. Alright, now let's talk about garbage collection. After deleting the object, how does it affect the memory? Okay, we also need to check the memory, that any unused object should be erased from memory or something like that. There should be a memory efficient, I mean there should be a management of the memory. Okay, so what is garbage collection? Garbage collection means that we all know that in the memory management it contains what does it contain? What does it contain, the memory management? It contains the objects, it contains the data structures, right? And you need to make sure that whenever there's any unused, or maybe something or some object is deleted, it should update itself, the memory should update itself. So in Java it's automatically done, we don't need to call any method or system to we don't need to call the garbage collector. Okay, in Python it is also the same thing, that the management of the memory is done by the interpreter. Every time we try to run, it is done by the interpreter itself. The management of the Python heap is performed by the interpreter itself. Okay, so it's just a little knowledge info, just in case if they ask you about the garbage collection, then you can just write down that the memory management, the garbage collection is handled by the interpreter itself, no need to interfere. Same thing goes for Java as well. Okay, but otherwise you can do some editing in, you can do some you can call the method of the Java, in Java, calling the garbage collector, but it's automatic. So you know same thing here as well. So yeah, it's done by the interpreter. Okay, so we discussed about garbage collection as well. And the last thing that we need to understand is containment. Containment means it's a little bit similar to inheritance, but the only difference is in inheritance we are talking about is a relationship, but in containment, or you can say in aggregation, it's a has a relationship. Okay, so the difference in inheritance and in containment, the difference is a relationship, and this is a has a. Containment, you can say aggregation. Okay, containment or aggregation. There is something like aggregation, composition, but no need to go into much detail because this is A level, so they want you to be they wanted to put this simple as much as possible. So aggregation, you can say there's something that has a relationship, something like that. And for example, I got two classes, class 1, class 2. Let's say the class 1 is aeroplane and aeroplane, okay, and class 2 is engine. So the engine is a part of the airplane class. It can become a part of the airplane class by, I'll show you how it is done. So in this way, it's more like a has a relationship. There is no inheritance. Okay, the engine is a part of the airplane. These two are classes. They can there is another one, like for example wheel class, or you can say the wing class. Okay, the wings class, right? So this is how containment works. All right, and also it should be filled when for example, if they ever ask you about to draw the diagram, it's something like that. If you always put a diamond type symbol, and it should be filled, okay, when if they ever ask you about it. So this is how you can create a diagram. And now let's do the implementation in coding. Let me comment this or just remove this. Okay, so class, again class aeroplane, and define, initialize, okay, def work engine, def start, print Yahoo engine started. All right, this is the class aeroplane. Now there's another um, class engine. Okay, same thing in here as well. And I want to say um okay, engine name is XYZ. Okay, so what will I do now? I'm going to cells dot in engine is equals to engine. Okay, and then I'm going to self dot int dot start. So I'm just going to call this right like that. And now if I try to create an object, so if I create an object, which means a1 is equals to aeroplane, right? And then I'm just going to start, using this. If I run this, and okay, didn't put this. Okay, so this is how you can do containment. So what's happening here? We created the constructor, and then we have put this, so it's connecting it. Okay, this is how you can say that this is aggregation. We have passed you can say an object, you can like it's looking like that. Self dot ing is equals to engine. Okay, and then I just call the method through this. Okay, so this is how you can do containment. It's more like these two classes are connected now. This class has become a part of this one. You can create as many class, you can connect as many classes as you wanted to, just doing the same pattern. Self dot this is equals to that. After creating so many classes and then putting in here, this is how you can do containment. All right, it's very simple, it's very easy, it's not nothing difficult in here. And yeah, that's how it is, right? So this is the whole thing: containment, garbage collection, destructor, and polymorphism. This is OOP part 4, and congratulations, I think OOP is completed now. And now we will move on to okay, maybe not completed because we haven't completed file handling also left. File handling in text file, binary file. Okay, and now we also need to discuss about exceptional handling. This would be O part 5. We will discuss it in the next video. We'll discuss this, and then we're going to move on to we will move on to binaries. There are searching sorting algorithms, and there is stack and queue, or maybe not. Searching, sorting, and then we're going to discuss about linked lists as well, linked lists and binary tree, and then we're going to discuss about sorting and searching algorithm, and then maybe the whole P4 would be completed. So there's so many things left. We will start from here. Okay, so I think it's enough for now. Thank you so much for watching, and I'll see you guys in the next video. Thank you.